So I'm going to do another presentation on processing my astrophotography. This one should be a little bit easier to read because it'll be in 1080p instead of UHD. So we'll start with some data that I've taken in the past. What I do is I normally do my stacking in Deep Sky Stacker, and then process everything else after that in PixInsight. And I only do that because Deep Sky Stacker is easier and faster than using the batch processing in PixInsight. Plus the files end up being smaller. So first thing we do is going to open up our files that we're going to use. So we're going to start with these right here. I'm going to look at these details and then go by type so I can pull up the FITS files. I'm not going to do all of them. I'm just going to do a subset here for demonstration. So we'll pick those. Open this up. See, we've got them right there. And then I'm going to open up dark files. And we'll pick all of these. These are previously dark files I previously took. Then I'm going to open up flat files. I'm going to pull these up. And I didn't take any bias or offset files, so that's it. I'm going to do a check all, which says I've got 11 light frames, 24 darks, and 50 flats. And I already have the settings set up for FITS files. I've got monochrome 16-bit FITS files are raw files created by a DSLR or a color CCD camera, in this case my CMOS camera. And this is what I've got. So set up, that's the matrix. See, okay. And that was under the raw FITS files setting. Okay. And the other thing I might want to check is the stacking settings. I like to use intersection so that all the frames, when I use an overnight where it does meridian flips, etc., it's not exactly centered. There'll be a little bit of overlap of one set of frames to the other. So I wanted to use just the intersection of all the frames. So that's why I picked that. Light frames, I like to use the Kappa Sigma clipping, which will take out satellite trails in a single. If there's a single frame in there, it's got a satellite, so it'll take that out. But you can use average or median or whatever you want to play with, so that's what I use there. And as far as others, the darks are whatever average. I've got flats set up as average, etc. I could use Sigma clipping for these as well. Alignments, automatic. All these other things are pretty much default, so that's okay. And at this point, we go to register. I want to check to see if I got the right, reasonable number of stars for stacking. 159 is quite a few. I don't really need that many, so I might get down a little bit. Oh, go up here, so it's not so many. It goes faster if you have less stacking. I don't know. So you just work with that with each image. It may be different for each session that you have. Where you don't have a lot of stars, you may have to increase it to the left so that it pulls out more. And then say OK. And this is just information about what you got your settings. You can check those whenever you want. And then say OK. So now it's going to stack all the dark frames. And it's going to stack all the flats. Or register all the flats. Yeah, register the darks. It's registering the flats, and then when it'll register the light frames, and then when it goes to stacking them to calibrate them together. Okay, the flats are almost done. Now it's going to register the light frames. Okay, computing the final picture. It's checking for the anomalous planes or satellites. And so you won't see much when you get the raw data back because it's not processed. But that's it. I just created a TIFF file called autosave001.tiff. And this is from data from last month, June 28th, on, as you see, 6946 and 6939. So now we're done with this program. We're going to close that. And we're going to open up that TIFF file. This TIFF file here, but we're also going to open up one of the single frames, and I'll show you why in a minute. So we're going to open up one of these single frames that we have. So this is one of those single frames in PixInsight. I'm going to press Control A, which is an auto stretch in display only. It doesn't actually touch the file. And this is the FITS file that was taken, a single frame of the FITS file that was taken. Okay, it's in black and white because this is not converted to color yet. But the TIFF file, I'm going to do the same thing and do an auto stretch, and it's going to be green. And that's because of the debayer that we have. But the key here is that the data's been stacked, calibrated, etc. And the green will go away once I use this single frame to set up the first process that I do, which is photometric color calibration. That's this right here. And what I'm going to do here is I'm going to use this file to populate this area that's called image parameters. And I'm just going to hit acquire from the image because all that data is in the FITS file. So I say OK, and then I'm going to minimize this guy. And we'll just move this out of the way. And now I'm going to apply standard average spiral galaxy spectra to this image. And I'm not going to change anything else. Just going to use all the defaults. So let that run. That'll take a little bit of time here. And assuming that it actually goes out and finds the catalog that it needs. Sometimes I get an error when it can't find the catalog that I need. The catalogs can be downloaded to your local machine and used locally instead of a server somewhere in the world, which I've done on my laptop, but on this main machine I'm always on the network, so I just use the servers that are available. And those servers are available, let's see, here's the database server list. I can't pull it down right now because this is busy, but I'm using the one out of France right now. And it's still downloading file data associated with this field of view that I want. And we'll see if that actually passes. I may have to make some changes on the parameters for it to work successfully, but 95% of the time it works. So we'll just see what happens here. It seems to take quite a bit of time. And if it fails, that's fine. It's one of the part of the learning curve that you'd have to go through is what works and what doesn't. Most of the time, this does work. But I notice it's really taking a long time to transfer some data here. So that's sometimes suspicious that it won't actually work. We shall see. This area of this image, the area of the sky I'm looking at is 2.5 by 1.5 degrees or something in that order because it's my refractor. And so it's got a lot of area to look at and a lot of stars that happen to be in this area. So now it's going forward. Okay, it's got what it needs and it's going through now and doing a plate solve on that image. Once it does a plate solve, it knows, it looks against the database, the stars that it knows about and their spectra, and it's going to adjust the entire frame based on the color of those stars. which is what I like because it's very consistent. It's more consistent than me trying to mess with the color calibrations manually. So that's one of the reasons I like using it. Hopefully I picked the right flats. This takes a few minutes. And after this, yep, it's pretty much done here. There we go. So what we'll do now is let's re-stretch this using the auto stretch, and you can see it's done a pretty nice job on the background and the objects. And we'll use some color calibration or color um, stretching to maybe increase the colors that are actually there in a little bit. But anyhow, what I've done is an auto stretch, so now we're going to go back to what it looks like before we do any more work. So the next thing we'll do is Histogram Transformation. And that's right here. By the way, the photometric color calibration produced this graphic and some other video. I'll explain what this is, but it's basically telling us how it dealt with all the various stars it used. So let's open up the real-time display. All right. So let's start this off. This is the histogram. You know, so all the data is way down here. So we're going to start stretching it. I'm going to hit this button here, which is apply. And it'll be oversaturated because the curve isn't on it, but we'll continue working on this. So I just hit the reset button, which is this button here, to bring it back to where we want it. And then I'll just continue to work on this like so. Now this is basically what do you want it to be. So I hit that, and we'll reset that, and that's what I'm going to work with. So that's what the data looks like right now. Then the next thing we're going to do is the curves transformation. And the only thing I do with this guy is I work on the color saturation. That's it. I don't do anything else with it. So I can go like that and really bring out the various stars and the galaxy, blah, blah, blah. But the background also changes. But I like going to about right here, and that's about where I usually work. Okay. And that's just about it. Now, the only thing that I may do in addition is after I do the photometric color calibration is I may use this automatic background extraction, which takes gradients out. And I do it using the subtraction, so we'll do that. And you want to do this before you do the histogram stretching, etc. But I'll just show you that you just basically say subtraction, and then you hit this button. And it can give you, you know, what did it do kind of thing. It took a little bit of stuff out on the right hand side. So this one might be a little flatter looking as far as the background. And you want to actually do that after the photometric calibration, color calibration, if you're going to do it at all. So that's it. That's basically what I do for my processing. So I hope you enjoyed this. I ran this on July 18th, 2022 at about 3:45 in the afternoon. So we're going to close this out. Great. Not going to save anything. And this is one of my images that I took last year. Thanks for watching.